This series of The Kamla Show from Silicon Valley is brought to you by Zoho Corporation. Zoho is the operating system for business.
Hello, I'm Kamla. My guest today is Bill Atkinson. He was known as Mr. Graphical User Interface when he was with Apple, and he is also an inventor and a nature photographer. Welcome.
Thank you.
Mr. Graphical User Interface. Is that the sobriquet that was given to you?
Oh, it's a role that I performed. I don't think people called me that.
Later on, perhaps? Because I came across this while I was reading up on you, that somebody mentioned you as Mr. Graphical User Interface. I forget where I came across that.
Well, I had a lot to do with the graphical user interface on the Lisa and the Mac.
That was your major contribution.
I've done a lot of things.
I know you've done you're a multifaceted Renaissance person. But when it comes to the Macintosh and Lisa, you did a lot of work for them.
Well, the quick-draw graphics primitives really enabled the graphical user interface to be practical. They were written in optimized assembly language so that we could sling the pixels and make a graphical user interface practical. Before that, computers, you put a byte in a memory location and a character generator ROM would make the character display on the screen. But there wasn't much flexibility about what you could put on the screen. Well,
take us back, because...
Okay, I'm talking about now the display. That quick-draw was about the display being full bitmapped, where every dot you see on the screen can be turned on and off in software. And that wasn't true in the earlier computers. In the earlier computers, they could only display characters or big blocks, and because they didn't have a full bitmap display. Now, one of the problems with a bitmap display is there are a lot of pixels to set and clear every time you want to write a character or draw a line or copy an image or something like that. And in order to do that efficiently enough, quickly enough to be practical, then the graphics routines had to be very, very fast and optimized. And so that's one of my contributions.
And then you did Hypercard,
Mm-hmm.
Mac Paint,
Yeah.
pull-down menu,
Yeah.
double-click.
Yeah. I convinced Apple that a mouse had to be in the box.
Oh, you did?
I convinced Apple that it had to use a white background. And there were rational reasons for all of these things.
Prior to that was a black background?
Yeah, the computers used to use a black background and then either white characters or green characters.
Yes.
And when you have text that's white text on a black background and then you print it, well, you're going to print it on white paper. So you're going to have to invert the text. If you're just doing text, that works fine. But if you're doing graphics, you wouldn't want a photograph to go negative when you printed it, would you?
No.
So the Lisa team initial user interface was a black background. And I argued that if you're going to do graphics seriously, you have to go to a white background like the paper that we're going to print on. And the Lisa hardware team was worried that that would draw more power. The screen would flicker more. They'd have to use a faster refresh phosphor so it wouldn't smear when they scrolled. That would mean they have to use faster memory to drive the video display, and the whole thing would get more expensive.
But were those valid concerns?
Yes, completely valid concerns.
Okay.
And it's true that they did have to use more expensive memory to support a white background screen. And ultimately, it was Jobs' call, but he listened to all the input and agreed that if we're going to do graphics right, we have to use a white background.
So you had the backing of Steve Jobs.
I convinced him.
How did you convince him?
By explaining that you don't want photographs to go negative.
He became a convert then.
Well, either you're going to do graphics or you're not. If you're not going to do them, then you don't have to worry about which, the screen is backwards from the printing. But if you're going to do graphics, particularly if you're going to do imagery, you don't want it to go negative when you print it.
Let's go back to the beginning. When did you first see and feel a computer?
I was not a computer science major at school. I was a neuroscientist. I trained first in chemistry and then biochemistry at UC San Diego. That was my undergraduate. And I was using computers there, but I wasn't a computer science major. When I went to University of Washington in Seattle, I was studying neuroscience. I wanted to study how does consciousness work? How do the brains work? So I was working with Doug Bowden at the Regional Primate Research Center. And we needed to use computers to control experiments. So these are experiments with monkeys where we had a cannula introduced into the brain, different parts of it.
What is a cannula?
A little glass tube, and it's hollow, and you can introduce chemicals through it to specific parts of the brain and see how does this chemical in this location affect, for example, the monkey's willingness to press a bar. And we mapped out the pleasure-reward centers of the brain. One of the things that we had to do, since every brain is different, like every face is different, but we all have a nose and we have two eyes, so you can map one brain onto another. So when
the contours are similar.
Well, there are landmarks.
Okay.
And you can distort one into an atlas. So if you have a standardized atlas brain and you want to say, well, the places that I stimulated, where were they on this standard atlas? You have to take sort of the landmarks on the atlas and match them up to the landmarks on the test subject and sort of distort this to map the data on.
So the atlas becomes the reference book of sorts.
Yeah, like sort of make, an imaginary perfect face and then take each individual face and distort it to fit it. But not the face, the brain. And so we were using computers there as part of, and this is where I got into computer graphics, is how do you take these data of where we've stimulated and map them onto a standard atlas.
So you were creating this atlas of brain and you're using a computer.
Yes. So I was using computers to control the experiments and to map the data, but I wasn't into computers. I didn't like computers. They're just a tool.
Even though you grew up in Silicon Valley where the computer revolution kind of started.
I didn't grow up in Silicon Valley.
Los
I grew
Gatos.
up in the Santa Clara Valley. It wasn't Silicon Valley till I came back to it, right?
This is true. This is true.
And when I left, it was Blossom Hill and Blossom Valley, and it was not Silicon Valley till I came back.
So
Okay.
while you were away in school,
When I was in high school, I didn't even know anybody that smoked pot.
oh,
I didn't.
and
I mean, this is marks the time. Nowadays, our preschoolers seem to know about everything.
okay. So there were no computers around when you were growing up, or you didn't know of.
I remember once we got one demo day with a computer, and what they brought in was a teletype terminal, and somebody was demonstrating this program that could tell whether you were a male or female.
Oh,
And you would type your name, and you would type a return, a line feed and a return. And I quickly caught on that the person who was defrauding us was telling the boys to type line feed and return, and telling the girls to type return and line feed.
oh.
So we
okay.
tried to trick it with names like Chris that might be either gender. And immediately I realized, so computers can be used to cover fraud.
Oh.
We can trick people into believing the computer is smarter than it is. And that was the only really experience I'd had with a computer in high school.
And then the major one was at Washington when you were in Seattle.
Well, down at University of California in San Diego,
Okay.
my undergraduate. There they had a big Burroughs 5500 mainframe. And you could go, and I had to learn Fortran and Algol, and you typed your program onto punch cards. And you took this deck of punch cards and you submitted it. And you came back the next day and you got a listing and it said, there's an extra semicolon on this and your job's been rejected. And actually I had a friend and teacher there, Jeff Raskin, who had the nerve to take his computer center budget and instead buy mini computers and set up interactive BASIC with a video terminal and a beanbag. And you could actually type some BASIC and try it right away. This was revolutionary because you didn't have to come back the next day to find out.
What year are we
mistakes were.
talking? What year are we talking?
71, maybe, 1971. Okay. He was in the visual arts department, and they were unhappy because he didn't pay the computer center for computer time. He used it instead to set up his own interactive computing facility that was much better for learning computers. It was designed around people instead of designed around optimizing the machine time on the big machine.
But why were you learning BASIC?
That's what was available.
No, I thought you weren't interested in computers and computer science. So I'm trying to understand, why were you learning BASIC?
Basic literacy. I mean, you take humanities and you take math, and you have to learn some languages. I took German.
So you learned German, but
I learned German in high school.
In high school.
Yeah.
Okay. Okay. So
I'm just saying that I didn't learn BASIC to do a particular job. I just it was available and I learned it to play with. I wrote little programs that made pseudo poetry.
Oh.
Pick one from this column and one from this column and one from this column. You know, noun, verb, direct object, and print a line and can continue. And it made silly things that somebody might think were poetry, but they were just a random association of words from a list.
So it was out of curiosity. You kept yourself happy.
I was playing with it.
Yes, yes, you were playing with it. But then when you were doing your PhD,
yes,
you got
Then I needed to use the computers to control the lab experiments and to do data analysis and to do plotting and conforming the data to an atlas. I've always viewed computers as just a tool. A really good carpenter is not in love with his hammer.
Some of them are.
If this hammer isn't available, he'll take another hammer and do the job.
But there are some who say,
I don't like computers.
Oh, they're tools for you.
I have jobs I want to do, and I choose the right tool to do the job.
So did Steve Jobs inherit that line of thinking from you, or did he arrive at it independently? Because he also says that it's a tool.
He does say that it's a tool. I don't know whether he got that from me or not.
Did you hear him say that before you came into Apple?
I didn't know about Apple Computer before I came into Apple.
No,
I came to Apple when there were 30 people.
Yeah, but
I never met Steve Jobs.
Okay.
I never heard that there was a company named Apple.
Oh.
I was working on my PhD up at the University of Washington, and I got a call from Jeff Raskin, my friend and professor from undergraduate, who said, there's something really cool started up, this new startup called Apple Computer. You got to come and check it out. And I said, no, I can't. I have to finish my PhD, or they won't let me do research in consciousness and brains. It's kind of like a basic enabling credential, like a driver's license. You don't have a driver's license, you don't get to drive. And so I said, no thanks. And he didn't take no for an answer. He sent me round-trip airfare with a note saying, just visit for a weekend, no strings attached.
So Apple paid for the ticket?
I assume so. I didn't. I just got the tickets in the mail.
But why did he think of you?
Well, I think he thought I was brilliant and would be an asset to Apple.
Okay.
I came down. So my dad lived in Los Gatos, and I thought, well, okay, I'll visit for a weekend. And so Steve Jobs spent the entire day recruiting me. He took me around and I met all 30, there were 30 employees, and they were all interesting people, smart people, seemed like they were having fun, seemed like they were, had a good attitude about making the world better. But that wasn't enough to get me to quit my neuroscience program. And Steve took me aside at the end of the day, and he said, you realize that hot new technologies you're just reading about now really were invented 2 years ago. There's a lag between the time something's created and the time it's available to the public. If you want to change the world, if you want to have an effect, you have to be ahead of that lag time. And he said, come to Apple, where we're inventing the future. You can help to invent it.
So did Jeff Raskin ever tell that you're very interested in changing the world? Maybe you're an idealist?
I don't know what Jeff Raskin told Steve, but he really must have put the bug in his ear, because Steve spent one entire day just recruiting me. And you know, if I can reach Jeff in the spirit world, I'll ask him what he said. He's gone now. Steve finished it off with a visual that really kind of hooked me. He said, think how fun it is to surf on the front edge of a wave, and how not fun to dog paddle on the tail end of the same wave. Come to Apple, and you can invent the future and affect millions of people's lives.
So what were you thinking when he said that?
Well, God, this guy's a good salesman.
You were introduced to his legendary persuasion.
I went back home in turmoil.
Oh.
And
Why the turmoil? Why the turmoil?
I had to choose whether to turn my back on 10 years of college. I had been studying to be a neuroscientist
I
for a long time.
understand. So that's why I'm wondering, why would you be in a quandary?
In 2 weeks, I had quit my neuroscience program. I never finished my PhD. I had moved to Silicon Valley. It used to be Santa Clara Valley. And I was working at Apple. So 2 weeks after Steve recruited me, I was there.
Okay, but I still haven't unboxed that black box. You're studying neuroscience, you know, you're
Yes.
unboxing the black box, you know. What was going through? Why were you in a quandary? Because you said you were really not interested in computers, it was a tool. What was it about Apple that put you in a quandary? What was it that you saw?
Why would I consider moving to
Yes.
Apple? This is making a difference in the world. You can come and invent the future.
That was the hook.
Yeah.
And what year are we talking about?
1978. April of 1978.
Okay,
So it's 40 years ago.
40 years ago. So were you an ABD, all but dissertation? You had done your literature review and everything for your PhD?
I had one course to finish and one dissertation, the dissertation being the harder part.
Yeah.
So I still needed at least another year.
You went back and forth in your mind whether I should or shouldn't or should or shouldn't.
Yeah, and my dad was really mad at me.
Oh.
Because he had co-funded my 10 years of college education.
Oh.
And he said, you're throwing away all this to go, you know, he didn't know that Apple would become something important.
Because he hadn't heard about Apple either.
Nobody had. There were 30 people at Apple. It was a little startup.
So it was something about Steve Jobs' way of talking and persuading you and what you saw.
He convinced me that I could have a good impact on the world by being at Apple, that my efforts would be leveraged in a way that they would affect the world.
What did they think you would bring to the table? Because you're a neuroscience major and you're joining Apple, a computer company. What did Steve Jobs think that you would bring to the table?
Well, I hired in as the application software department. This is kind of funny. There was only one of me, right? And at first, all I did was kind of a librarian of cassette tapes that the user groups submitted little basic programs, and I would assemble them into sharing tapes that then would mail out to the user groups, and they'd pass them around. And one of the things that I did very early was I realized that in order to build in a cumulative fashion, we needed a better development environment. Apple Basic didn't even have local variables. In fact, the Apple Soft Basic that Apple had put in the ROMs now and from Microsoft, only the first two characters of each variable name made any difference. You could have a really long Rumpelstiltskin, but really it's RU, right? And if you have another one that looks the same but has the same first two, it would step on it. And it wouldn't warn you that there's a conflict. The program just would have bugs in it. And so we used to keep actually charts of A through Z through zero and A through Z through zero. And when you use a variable, you'd check it off. But it meant that you couldn't write a module of software that somebody else could call because they'd have to worry about stepping on your variables. And so one of the first things that I did is I heard about this UCSD Pascal system down at UC San Diego, and I didn't know about them when I was there. But they had made a virtual machine called a P machine that would run on different operating systems, but would allow you to build code in Pascal with modules that were, you could write a module and somebody else could call it. And
so you're not stepping on each other's
right.
toes.
So you could build in a cumulative fashion. And I said, we have to port this to the Apple II. And my manager said, no way.
Who was your manager?
Roy Milan, something like that. Roy Martin. Thanks, Andy. So Roy Martin said, no, we don't need this. And I went over his head to Steve and I said, look, I think this is really important. We need to do this or we will not be able to build a cumulative library. And he said, well, I think you're wrong. I think our users are quite happy with AppleSoft and Integer Basic and a 65-2 assembly language. But since you're very passionate about it, I'll give you 2 weeks to convince me otherwise. So that same day I was on an airplane down to San Diego, and I stayed the whole time in it was Ken Bowles' lab where they were doing this UCSD Pascal project. I stayed there the whole time and worked on it, and they had already done all the hard work of making a 6502 interpreter. And mostly what I had to do is plug in the disk routines and the graphics and connect up the graphics. And I never bothered to get a hotel room. I just slept on the lab bench because we were working 24/7. And 2 weeks later, I came back with the UCSD Pascal system working on the Apple II. That ended up being the bootstrap that we used to make the Lisa. The Apple II running the UCSD Pascal system allowed us to develop the Lisa.
So your interest in creating this development environment, would it be fair to say that because you had worked in a PhD program, in a research kind of an environment where you had to have a stable environment to tabulate everything that you were working on, so were you used to that kind of a thing? Do you know what I'm saying? You were used to...
Well, I knew several computer languages by then, and Algol is very related to Pascal, where there are local routines and modules you can build in a cumulative fashion. I understood that software development, certainly at an industrial strength level, requires a modularity. And Apple were a bunch of hackers who didn't really understand software development. They were good hackers. Woz was an amazing hacker. An example here, when the UCSD Pascal system took a lot of disk space, and it wasn't fitting very well on the 13-sector disk floppy disks for the Apple II. And Woz had just found a better way to pack the data onto disk, called the 16-sector disk format. And he would use the same hardware controller, but just a little bit different formatting on the disk. He could cram more data on it. And so we wanted to use that for the UCSD system. So Woz flew down while I was there in San Diego. He flew down, and watching him program was really interesting. He would type. I said, what was the pause? He says, forward branch, I was computing the offset, and he entered it. He didn't go back and back patch it.
So mathematically...
So he'd say, I have to branch to here, and he'd figure out what instructions he was going to need and how many bytes they were going to take and what address to jump forward to get there. And then he actually didn't even use an assembler. He typed in hex and disassembled to get a listing. And one of the jobs that I had to do is disassemble the whole 16-sector disk routines and then comment each line, because there was no source code. There was no comments, and I had to, you can't have source code that doesn't have comments that explains how it works. And I gave him back a commented listing, and I said, did I understand right what you're doing? And he said, I'm amazed. You got it.
Okay. So just to close a thought about going back to your research work, because you talked about modularity, what I was thinking is because you worked in a research lab and because you were creating this brain atlas, you had set up a system of how to work. The lab had set up. So there was some sort of modularity in the lab environment. Were you trying to create that at Apple because you said, okay.
No connection.
Okay.
Just I was using a high-level language like Algol, and compared to BASIC, BASIC was very wanting. It wasn't about the system at University of Washington, it was about the language ALGOL versus the language BASIC, and particularly Apple's BASIC, which was only significant to the first 2 characters.
Okay, so you come back from San Diego with Pascal, and then you install it?
I brought it back to Apple, and I showed it. One of the first people I showed it to was Mike Markula. And
who was the guy who funded Apple?
Yeah, good man, still good friend all these years. And one of the first things he saw was that it had an 80-column upper lowercase text editing. And just the text editor was of interest to him, let alone the development environment. And Apple ended up, so from the time I got back to the time that Apple actually shipped that, I think was like less than 4 weeks or something. And I made all the floppy disks myself. I did the disk duplicating. We didn't have a bulk disk duplicating machine. We just used Apple IIs with 2 drives, and we'd suck up one disk and then just write it out and another. If there was 5 or 6 disks in the UCSD Pascal system, so we had 5 or 6 Macintoshes, each one making one kind of disk.
Hard work.
Oh, it was tedious, but I wouldn't call it hard.
Tedious, but because you are passionate, you spend time doing it.
Yeah.
Okay, we'll come back. We'll come back and talk to you in part 2 about what you did with Lisa and what you did with Macintosh.
Okay.
So we'll be back with Bill Atkinson. In part 2, we'll talk to him about how he started working with Lisa and Macintosh. If you missed any of our shows, you can check them at kamlashow.com. We'll be back again next week with another new conversation. Until then, goodbye.
This series of The Kamla Show from Silicon Valley is brought to you by Zoho Corporation. Zoho is the operating system for business.